Hey guys, welcome to this video where I chose to take this NAEP item that says if n times n is equal to 729, what does n equal? So the answer to this would be the square root of 729, right? But I know that when my students look at this problem, they typically see n squared or n times n. They see two n's here, so they think that it's like 2 times n. So they think n is going to be half of this number, which isn't right. So I actually have used this GeoGebra app that I'm going to show you here in my class to make a connection between squaring and square roots, because I noticed with my high school students there seems to be a pretty big conceptual misconception with squaring and square roots. So what I decided to do in my class, and at Belgrade we're teaching an integrated model, so this content really fits this integrated idea pretty well. And my definition of integrated means take a geometric concept and algebraic concept and see the relationship between them. You know, geometry to me is kind of the visual understanding, and then the algebra is just the symbolic and, you know, equation side. But we can make a connection between both of those thoughts with this this conversation here. So when you square a number, like x squared, some number squared, that's just equal to that number times itself, right? So this can be represented as the area of a square. And so the reason we can use the area of a square is because area of a rectangle is length times width. But in a square, our length and our width happen to be the same units or dimensions. So we're going to call the side the length like x and the width x. And since this is a square, all four sides then are going to be x units long. So the area of this, when you take your length times your width, we're really taking x times x, or x squared. So like with my students, I mean, that's why we even call it squaring a number, because you're basically thinking of a number as a side length and you're constructing a square based off of that that number. So when we square something, we're actually finding the area of a square. So the relationship between squaring and square roots, the way that I look at it is, if you know the area of a square, if you know a number that you're going to take the square root of, you can think of that as the area of a square. The square root is the number that gets you back to the side length. So like roots of a plant, it's kind of, you know, when you take the square root of an area, it's saying what number is making that square, right? What side length would make that square with the given area. So to represent this idea of making a square, given a number, to find the area is like squaring the number, and then working backwards to the square root is thinking if you're taking the square root of a number, it's really the area of some square, so the square root of that area would be the side length that makes that square. This GeoGebra app here, I think does a pretty good job illustrating these two concepts in their inverse relationship to each other. The way that this works here is I've got a square that I put in standard position. So we've got a vertex at the origin, and then this slider here that I made super long because it goes up to, I think, an area of 1,000. And you can always make, if you ever want to change the value of a slider, you just right click it and go down to its object properties, and I changed the max of my slider right now to 1,000 because this NAEP item is asking if n times n equals 729, what's n? So I wanted to make an area big enough to represent the 729. So the way that this works is the slider here actually changes the area of our square, and the side length of that is going to change accordingly as well. So given the area of a square, the side lengths are actually the square root, right? So if we have an area that's, say, 100, then the side length would be 10, right? The square root of this area is 10. So if we slide this up to, say, 729, let's answer that NAEP question. So I like to think of it as creating a square with an area of 729 like this. And the question is what's the square root of 729, which is 27. And you can see on the number line here on this x-axis, or if we even went up to the y-axis here, we get 27. So this app, I think, does a very good job explaining the relationship that given a number, like you could even ask yourself what's 20 squared. So you can just move your area, not even pay attention to the area value, but get your side length to be 20, right? And this can be pretty close to get to 20. So we can use this side length value here as our guide. So we got to 20, therefore its area, a 20 by 20 square, or 20 squared, is 400. So you can use this app here to make the side length whatever we want, or we can make the area change, and therefore we can look at the square root. So the way that I tell my students, if you know the area of a square, the side length is automatically the square root of the area. And if the area is a perfect square, then our side length will come out to be a whole number. Otherwise, it's going to be some irrational length. In GeoGebra, by the way, by default, rounds to the 100th place, but since we're talking irrational values, we may want to change that. So if you go up to options and you go down to rounding, you can see that we can round to up to 15 decimal places, which might be interesting to look at. And you can see that a more approximate value of the square root would be, you know, this longer decimal expansion. Okay, so play around with this app here, see if that makes sense with area tying into square roots. If you have a side and you square it, you get the area of the square. If you take the square root of a number, you're kind of I like to think of it as you're taking an area and figuring out what side length makes the square with that given area.